Hello, buddy. Happy Thursday,
Hey.
Jake. How's it going?
Hello.
Hey there. Hello.
We've got a long-awaited guest who I definitely missed at least 1 to 2 emails from you at some point along the way, and then emailed you back and was like, oh my gosh, I missed these emails very long ago. Please, let's get you on the show. But
Please forgive me.
yeah, please forgive me. It is Will Francis himself. How's it going?
I'm honored to be here. It's going great. Thank you.
You got a very appropriate background as well. A lot of Colorado propaganda.
Yeah, I'm a Colorado native, so I love Colorado.
It's a great state. It's one of my favorites. It's in my power ranking. It's probably it's top 5 for sure. I think where exactly it sits.
Top 5.
Yeah,
That's pretty good.
I love it. Yeah, it's great because it's great all the time. Anytime you go there, it's great. There's not a season that sucks. So.
It's very true.
Yeah.
It's very true.
And it's importantly, Jake, it's unlike your criteria of there's not a season that sucks and all the seasons are the same. They're all different and they're all good. That's the thing. So I know you hate seasons down there, but
Yeah, I like 50 weeks of summer and 2 weeks of early fall.
I can understand
That's my criteria.
you don't swim in those.
Yeah, I don't swim during early
Close
fall.
the pool.
So. Close the pool during early fall and then back on 2 weeks later. But I'm a weirdo.
We just had a week of near zero temperatures here, so I can relate to warm weather. Sounds great.
Yeah, all my family back home in Alberta and Canada are not having a good go of it these last couple of weeks. It's been very, very cold. Snow days and cold days, not snow days, just cold days. Like not safe to be outside. Don't come to school. Don't come to work. Like that's something for a prairie Canadian to say. It's not safe to go outside. So.
Well, other things that may or may not be cold, Jake, as our drinks. There we go. How's that? Landed the plane.
A+ segue. Love it.
Well, Will, what did you gather over there in Colorado? It's a little earlier on your side of things.
It's a little early, so I made a Manhattan, and I made it pretty small. But it's not my favorite drink. I do love Manhattans, but I knew we were going to talk about my history with Roccor a little bit, and it was kind of our official drink at Roccor. It seems like one of our founders, Doug Campbell, was really into Manhattans, so we would often, as the company grew, we would make Manhattans on a Friday evening, and as the company grew, it'd get to be, I'd make 5, and then I'd make 12, and then I'd make 20, and then I gave up. I had to pass on the torch. People had to make their own Manhattans. But yeah, Manhattan,
something like the can you feed the whole team with a pizza theorem of like, can you reasonably make this many Manhattans? It's when your company starts changing.
Absolutely, it's probably a good metric.
I just love the attitude of it's early, so I made a Manhattan, and it's only a single. So
Very small. I'll probably sip it slowly. I do have some work to get done yet today.
Okay, good.
What you got down there, Jake?
I got myself a craft beer today from up north, Monterrey. This is Rey. So this is the Cerveza Artesanal del Norte. This is a Mexican IPA. So pretty stoked for it. Yeah. Nice, simple one. Not a fancy. These guys don't mess around with their label. They just put a little.
Just give me the words.
Yeah.
It has like it's got like a design sense, like it's a ride in Fantasyland in Magic Kingdom. Like it definitely smacks like something that would be sold near Cinderella's castle.
I think this profile here is the mountains in Nuevo Leon. That's probably the Monterey mountain skyline or whatever you call it, right? So, yeah.
All right.
That's what I'm doing. Yeah.
That's good stuff. I got a wacky looking one. I've got this thing called a power juicer, which is kind of a wacky looking one. Icarus Brewing. So I thought this was nearby. Where's this at?
Sounds fancy.
Yeah, Lakewood, New Jersey, so not very far away. A little Jersey beer. This was another set that I picked up over the Christmas time shenanigans that was happening. So it's actually pretty delicious. It's definitely not like a wintry situation, but it's quite quite juiced.
I mean, a double hopped Imperial IPA can be pretty hardy.
It's hardy, but it's very like the juice is not. They're not laying off the juice kind of situation here.
Okay, it's a little fresh for the winter. Is that what you're saying?
Yeah, which is good. So I'm into it.
Excellent.
All right, where are we starting? Because maybe we should start with the thing I said right before we went live, which is, well, you've lived the entire circle of life of a space industry professional. You've done, I think, all of the cycles at this point, from presumably working somewhere before Roccor to then co-founding Roccor and then it getting acquired and then going to work at other places and continue the cycle. So maybe you can give us a little, like, previously on Will rundown of a longer version of that storyline.
Yeah, absolutely. I think, you talked about the founding of a company. Roccor was a fairly small company. I feel like we had really good timing. It was a time where it was good to build a small company. And it's a fairly, there are a lot of folks out there starting small companies now. There's a lot of small startups doing really cool stuff. And it's a fairly approachable thing what we did. We, over a period of 10 years, basically, we founded a company, developed some cool products, and then sold it to another company, merged with Redwire. It was, I've been through the whole, I've seen the industry from all the different angles. I've been an engineer, consultant, founded the company, sold the company, went public, and now I'm just doing business development at a rocket company. It's great. Kind of a little bit of the background is, I had a mechanical engineering background and spent about 20 years in deployable structures, and got pretty deep into architecting large deployable structures. So I started at a company that was kind of a materials company, developing new composite materials for space structures. While I was working there, I got a master's degree in something related to composite materials.
It sounds like you're trying to hide it. It sounds like that's like some stealth shit, to be honest. It's something related. Not mysterious at all.
Didn't mean to be mysterious. I just didn't want to get into, geeky material stuff. Unless you want to, I'm happy to dive into it. But,
I'm going to need a couple more rays before we do that. So.
And then I was as an analyst, became a consultant. And that kind of really, honestly, being a consultant opened my eyes to a lot of things, because you could come in and sit in all these different startups, large companies, as well, government entities, and get a feel for how they operate, work with teams. And that ended up giving me kind of a network and then kind of the confidence to jump in with some other folks and start a company. And we started Roccor in 2011 with the idea of doing deployable structures for the space industry. It's kind of 2011, there was a lot of kind of turmoil at that time in the industry, or I should say the industry was changing, from being very much government driven to being more commercially driven. So we kind of saw an opportunity there, and it really all started with a team. Jim Collins is an author from the area who writes business books, and he liked to say, first who, then what. And that's kind of what we ended up doing. We found a really cool group of folks, myself and Doug Campbell. A guy named Greg Fruberry was involved initially, and saw the opportunity to put together a really good team, built a really productive culture, and kind of went from there. And really, what's interesting is there were a bunch of us kind of in an incubation center, I'll call it. We had just rented a commercial space in the Front Range and kind of invited cool people to come sit there and have an office. And out of that group came Roccor, but also a battery company called Solid Power came out of that same group. Doug Campbell Ended up kind of running that for a while. And another company called Tendig that does antennas now, pretty successful deployable antenna company, came out of that same building. So yeah, kind of an interesting little incubation center we had going on there that turned into a bunch of successful companies. Some of the unsuccessful ones as well. There were some things we thought didn't work out. There's plenty of those. And yeah, we started Roccor and grew it to about 70, 80 people probably by the time we got to 2020, which is when Redwire came along and acquired Roccor. Much of the same team is still there in Longmont, doing really cool stuff. If you track Redwire, they've posted or published some stuff recently on supporting the Link 16 communication architecture. It's part of the Space Development Agency constellation. They have, Link 16 communication, secure communications for anything from handheld radios to helicopters that now relay through space. And it's a pretty awesome capability for the military. And yeah, that Roccor group is who builds those antennas. So really proud of that and the stuff they're still doing.
How did you pick deployable structures like back in the day? Why did that feel like a thing? Well, there's maybe two parts to this, which is number one, it's a deployable systems and deployable structures sounds like such a niche thing, but also it sounds like everything that a spacecraft does when it does anything sufficiently interesting. So it sounds like both very niche and very broad. So I would love like a primer on what was the purview of Roccor and how you decided that should be the purview that you focused on.
It's a really good question, but and if you think back to 2011 when we started, these really capable kind of ESPA class spacecraft, I'll say in the 100 to 400 kilo range, didn't really exist. There were definitely really small satellites that could do things. There were CubeSats, but the military, for example, wasn't using 250 kilogram satellites to do stuff. And there were some technologies that needed to be developed to enable that. And one of them was deployables. You couldn't go out and at the time go out and buy a 6 kilowatt solar array for a washing machine sized satellite. It just didn't exist. And similarly, antennas that were kind of designed for that size of spacecraft didn't exist. So we saw the opportunity to make those small satellites have kind of big satellite capabilities with the deployables. That's really what started it and why we went into deployables.
That is a really interesting time period to decide that too, right? Like 2011, I mean, I always credit that time period as like why I got into this stuff, because I was in college in Florida from 2009 to 2011, which is just like the moment the industry changed from the space shuttle going away, SpaceX starting up. Felt like that was the shift that happened in that time period. So yeah, it's like, I don't know if you could have chosen a better year to decide that like, I'm going to stand up for the sub 400 kilogram spacecraft.
Well, I mean, it's also kind of, it was a good decision, but it's like, that's also pretty risky. Like I can imagine like that could have gone in a very different direction and no one really knew. Like, everyone was hopeful, but no one really knew where that was going, right?
Absolutely. Yeah. Yeah, absolutely. We bet on a lot of things, and that's one of the things we bet on. We had other things that weren't as successful. We had some diversity in the kind of the products we were developing, but really we went all in on the deployables for, kind of that class of spacecraft, and there was some luck involved. We could have went all in on the CubeSat platform, and let's make CubeSats, really capable. And it probably, maybe that'll happen someday, but at this point, there aren't very many high-value CubeSats going up.
Ouch. Take that, CubeSats. Yeah. How do you feel about that, Jake, as a Marco defender?
It was a pretty cool example.
Was that it though? Was that the high watermark for CubeSats? Was Marco?
I I don't know. I know.
I feel like I kind of haven't thought about CubeSats since Marco. Honestly, this is the first time I'm realizing this.
Yeah.
Kind of it.
Well, okay.
I mean, Planet's got 8,000 of them, and Spire launches a bunch. You know.
Yeah, but is that the issue though? Is that it's not high profile? It's just
Yeah, they're just doing their thing.
Like how many CubeSats are launching on every transporter mission, and how many are delivering value, right? Like that's
true.
Have you done a in-depth inventory of the last transporter missions to like learn everything about each payload?
Definitely not. Yeah. All right. All right.
Yeah, it's a fair point. There are, we get a lot of capability from CubeSats these days. But yeah, they're, made in volume. They serve a purpose like, planet, Earth observation. And, but, they did it in such a way that they could build those things in high volume at a pretty low cost. It's very vertically integrated. So there wasn't an opportunity for a company like Roccor to come in and give them a capability that they require to make that possible.
Yeah. Well, that's the kind of the funny thing about CubeSats is that they are the whole win of a CubeSat is that it's like all these standardized interfaces. So you just kind of like buy the parts and you can kind of assemble whatever you want to do. And it's all, the shape's the same, the weight, everything's kind of like, figured out already. So all these like new constellations that have like volume advantages don't need that flexibility, right? So it like makes more sense to just make a not CubeSat, just make whatever exact form factor you need because you're going to make 5,000 of them. So it's all right.
Yeah.
You were the first one to say SPAC, and I'm actually curious about if we can get back into the SPAC craze, because this is another thing that I haven't thought about for a couple of years because everyone stopped going public by way of SPAC. I mean, what's the deal with SPACs? I guess. What was your experience of that era from the inside?
Well, I'll tell you my experience. I mean, I'm not an expert on SPACs, but I experienced one from the inside. And I can tell you my experience, which actually, interestingly, when we were acquired by Redwire, they were already in the process of going through the SPAC acquisition and becoming public. They just couldn't disclose that to us until we were part of the company. So I think we became part of Redwire on a Thursday, I think it was, and then it was Monday, Tuesday of the next week. They said, "Hey, welcome to Redwire. Let's get acquainted. By the way, we're going public now." So a big change becoming part of Redwire, but it's a week later, and now we're going public. So it was fast moving, interesting time, but. I think, if for example, Redwire would have gone public just directly without the SPAC mechanism, it would have taken a lot longer. We may have done it anyway. But I think, the important thing to point out is that we ended up at Redwire on the New York Stock Exchange with Redwire stocks. SPAC was just one of the mechanisms to get there. So has a bad reputation, I think, because it doesn't filter out as many companies. The whole process of becoming public filters out a lot of companies. You have to have some discretionary budget. You've got to have some funds to invest. You've got to have, very professional financing. You've got to spend a lot of time, and that filters out a lot of folks. The SPAC mechanism does not filter out as many folks. But at the end of the day, it's just a mechanism, and just because a company is a SPAC company doesn't mean they're not going to be successful. I think that's the way I look at it. So
forgive my web software nerd comment that may only make sense to Jake on this call, but probably other listeners. But turns out SPACs are like the PHP of going public. Like there's no barrier to entry. You can just do it, and then that's why there's like a lot of people that hate it and a lot of people that like it. I mean, it is. The other aspect was you saying it didn't filter out as many people. It also happened to be at a time when there was a lot of companies that needed filtering out. Like there was a solid amount of those that were going through the process that most of the industry was like, I don't know about this. Like I'm not seeing it on this one. So that plus the lack of filter, I think made it a bigger news cycle than it probably deserved to be.
Yeah.
It's a really interesting thing because what a SPAC is a merger with a company that's basically already gone public as a shell, and it's basically a bunch of experts that are experts at going public, and they build this shell, and then they merge with a company that's ready to go public, and it just accelerates the process. So at the end of the day, you just end up with your stocks in the New York Stock Exchange, and the folks that buy stocks decide what to do. I think, unfortunately, these days, after having gone through that and all the folks that didn't do so well through the SPAC process, it kind of has a bad name. So for companies like Redwire that happen to do a SPAC, it doesn't help them. But at some point, they'll just be a company on the New York Stock Exchange, and people will forget they were, they used the SPAC mechanism to get there.
Hopefully.
Can you name? We should do this quiz. Jake. Can you name all the companies that went public by way of SPAC? This would be a fun quiz.
Astra.
Black Sky,
Redwire.
I think.
Black Sky. Yeah.
Momentous was trying. Virgin Galactic did.
Virgin did. Momentous.
Was Virgin Orbit in the process of doing it? I forget.
I can't remember now.
Yeah. Rocket Lab.
Rocket Lab. That's right. Yeah. Huh.
Yeah. Planet? I forget if Planet was a SPAC.
I can't remember if Planet did.
I think it was. It must have been.
It must have been.
It was that era. No one was doing the paperwork if they didn't need to at that time. Yeah. Well, and then the other aspect that we didn't talk about also, and this might be maybe more to the point, is that your going public by way of SPAC didn't require that you had a deck that said all the satellites are going to be launched in the next 5 years, which all of the companies that went public by way of SPAC that we were feeling weird about were like showing the hockey stick chart of Astra, notably, of like, we're going to do 3 launches next year and 300 the year after that. And it's like, okay, I don't know about, maybe we should take a chill pill on that one real quick.
You kind of double SPAC'd. You like SPAC'd into a SPAC.
Exactly. We took a 80-person company in Longmont and went public in 9 months.
A whirlwind. And then you were like, all right, well, that was fun. Maybe I should sell rocket engines to moon landers and other things. What was how did this happen?
Yeah, absolutely. At Roccor, I kind of ran the engineering side for maybe the first half of it. Eventually, I was the CTO. We brought in a guy named Chris Pearson as the CEO at Roccor. And eventually, I moved over to the business development side. And other folks came in, and kind of managed the engineering team. And then when we got acquired by Redwire, that's the role I was in there. And, it was interesting from the standpoint of, being a part of setting expectations for the market and then trying to meet those expectations. And that was a roller coaster ride. But yeah, having gone through all of that, leaving Redwire, took a little bit of time off. And then my buddy, Chris Pearson, had moved on to Agile prior to me joining Agile. And I looked at it and I actually wasn't ready to go back like full in on a company or a responsibility that required, 100% of my time plus every week. And that's what Agile is. It's a rapidly growing, fast-paced company. But I saw a lot of similarities to, what I loved at Roccor, which was, there's no big egos. There's just a super productive kind of culture and team that's making awesome stuff happen every day. And, kind of being exposed to the space industry from the deployable side, and you kind of asked why we chose deployables. What's exciting, one of the things that's exciting to me now and what's changing in space now is the need for spacecraft to just be more dynamic. Space Force talks about maneuverability without regret. There's the Space Force just formed because space has become a contested environment. And so satellites aren't static, right? They move at thousands of miles per hour or whatever, but historically they've just kind of sat there in their orbits. And I think between military needs, commercial needs, and what I hope is becoming even a more productive science community as well. We just need this, our assets to be more dynamic. We need them to move around more. We need to be able to change orbits. We need to be able to do Mars sample return. We need to do more missions like that. We need to be able to avoid conjunctions. And satellites, I think, just are going to become more dynamic. So I was interested in a company that's trying to solve that problem, solve the propulsion side of that problem.
That makes sense. I can get down with that sort of like economic need, right? Because it's like if launch is getting cheaper, like just straight up, it's just cheaper to put something in space. That means that you don't have to spend as much as your budget on the payload, right? Because if mass is really constrained because cost is so constrained, then you want to just like you want every dollar to go towards the actual useful payload at the end of the line, right? Like whatever is actually doing the thing you want to do there. But if you take a little bit of pressure off that, and it's not so expensive to put your thing, your doodad in space, you can add a little extra capability to it, a little bit of different power or propulsion or navigation or whatever extra sort of like infrastructural pieces to the satellite that can help it do its thing in different places or at longer time periods or whatever, right? That's kind of a pretty simple economic way to look at it, I guess. That's cool. I'm digging it. I'm picking up what you're putting down.
Turns out he likes rocket engines. This guy, this Mars nerd.
Yeah.
Think about all the missions we often talk about now that we just didn't talk about 10, 20 years ago. There was always space domain awareness, but now we're talking about satellites that change multiple orbits and approach objects in space, whatever they are. If they're a conjunction risk, if they're an adversary spacecraft, who knows? We're building spacecraft that change orbits multiple times to investigate objects. We're doing all kinds of things in lunar orbits. We have a lot more hardware going into lunar orbit than we used to. Even like SpaceX, they do maneuvers to reduce risk of conjunctions. They do it with EP because they can right now, but I think as space becomes more crowded, we'll see the need for satellites to just be more dynamic. And, as we take more advantage of it with the growing space economy and we're just putting more hardware up there, we're going to want flexibility to change, business models or adjust business models and get to different places. And I just believe we can't afford to have the capability only to get to a very specific orbit and stay there. I think we need a little more dynamic capability now.
We had Lars and Chris Pearson on, Lars Osborne. I'd say Lars because he's first name basis with Jake and I, but maybe not the people out there. On Miko a couple of months back at this point, and I asked him a question that I'm curious to get your take on too. I was talking about the fact that in the space industry there are very few and almost none left suppliers that sell propulsion for launch vehicles and lower stages of spacecraft. But there's a lot more that sell propulsion to satellites or spacecraft or landers or whatever the case is. And it's a weird, it's a very strange, it's not strange if you're in the industry, but if you were to tell someone that is not familiar with space to explain that there are very few third-party suppliers of engines that go on the part where you're not yet in orbit, but there's a lot that sell it once you are in orbit. It's a weird thing to try to explain to somebody, and I'm curious what your take is on why that is the case these days, and if you feel like either one of those is going to change at any point in the future.
Yeah, there's definitely some nuance there, right? When commercial when very commercially focused organizations weren't doing launchers like SpaceX, they weren't as concerned about vertical integration. And so they would have entities like Aerojet, Rocketdyne develop engines for those launch vehicles. But now you've got the SpaceX example, and there are other commercial companies starting up to provide low cost orbit, of course, and we just saw Vulcan launch, which is really cool. But yeah, I think the way the new launch companies look at it is launch is kind of propulsion. The whole purpose is to get something from the ground to there. So they tend to vertically integrate it, right? They kind of start with the propulsion and build out from there, rather than start with the structure of a launch vehicle and then buy the propulsion from someone else. They kind of start at what they see as the core of it, which is the rocket engine and the propulsion, and build out from there. That's just kind of how they do it. Part of it could be that there wasn't kind of a new space, low cost or reasonable cost supplier of launcher engines, right? And if that exists, if someone creates that, will there then be a need for it? And will there be launch companies that take advantage? Maybe it's just a chicken and egg thing, but that's kind of what I see when I go talk to the launch companies, like ABL is a good example. Propulsion is what they do. They started with propulsion. They don't want someone else doing their engine in their case. It's just kind of, and it's, it could be the environment they started in. There just wasn't any option. But that's kind of their culture there. And they're good at it. So that's how I see it. And then, on the space side, it's different, right? Their propulsion is a part of a satellite, but it's not as big of a part as it is for a launch vehicle, right? I mean, it's somewhere between 5, 10, 15% of the cost of a satellite goes into the propulsion system. Whereas I'm guessing it's much larger than that for a launch vehicle, right? So, companies will specialize in the things they're good at, which could be attitude control, pointing very accurately, or building large volumes of satellites quickly. Whatever they do, it's not a obvious choice to vertically integrate propulsion. If there's options out there, good options out there at a reasonable cost.
Yeah. I think people still understate how much of the rocket is the engine. I mean, that's what the product is. So it's like, when you kind of think of it like, exactly. Why would, what does a rocket company go buy an engine? It's like, the engine is the thing. The question is, do they go buy the tank, right? That's really what it is, right? And it's always been like, kind of, ULA always really confuses me, because like, from a hardware perspective, like, what is it? It's some aluminum tanks, right? I think ULA's value is often more their operations and their navigation and their delivery, like all the service part of that, because the engines aren't their IP, right? Like they don't really have any control over any of that. They just buy it. So it's an interesting, like, the ULA scenario is kind of a weird rocket to me in that sense. It's just like I don't really know what the situation, like, it's weird to me, but
it's weird.
I mean,
especially
most of
when
the time,
you factor in them like buying solid rocket boosters and then upper stage engines too. Like, it's
all the propulsion is not theirs, right? They're just like, what is their IP is kind of an interesting question.
And they've never made any move towards that, which is also interesting. Like, they've never had any intent of like, what if we hired a couple people that could do rocket engines?
Yeah.
That's
But like, if you think about Falcon though, like Falcon is very much like it's a bunch of Merlin engines with accompanying tanks and a lot of great software. Like that's what the
even to that effect, like the physics problem is like, how few tanks and how little tankage can we have so that we can have all of the mass fraction available to everything else.
How do we do more engines and fewer tanks?
If they could build a launch vehicle that was just engines and didn't take any fuel, they would do it in a heartbeat. Like they're
a boneless skin eater, if you will.
Yeah, the boneless skin eater would be like instantly. They'd all be all about that. It's just funny that it's such a stark handoff of like, the flowchart of how to decide what you need as a rocket engine is, am I in orbit yet? If yes, go buy it. If no, you got to build it. I don't know what you're doing. Like, it's kind of that is the whole flowchart, and it's interesting. Yeah. How do you then approach when you're in your role? Like, you don't have to go open all the books for us and tell us all the secrets. But if you want to just say this is part of your related to composites degree, that's okay too. What is the approach on like when you start talking to somebody who wants to buy some engines from Agile? How does that process work? Are they looking for a certain aspect of performance? Like I don't really care how much thrust this engine has, but I need it to be able to do X, Y, and Z, or I really just need to get to this spot in space. You tell me what is the best offer you can give me, or like what's the best match? What is that process of figuring out what somebody's actually looking for?
Mm-hmm. No, it's a really good question. I will relate it to launchers. I will say launchers will have effectively small rocket engines upstream of the main engine. They'll have things like pre-burners, they'll have gas generators. Those things we do actually. So we provide that kind of hardware to launch companies because it's, the physics of that are kind of more in line with the in-space propulsion that we do than a, multi-stage big, like, liquid propellant main engine, which is a whole different kind of, almost a different discipline in a way. So we actually do launch vehicles. We just don't do main engines. We do all the little components upstream from that. Right. But yeah, more of our business is satellites and kick stages and things like that. And yeah, the way the conversation, part of our business is lunar landers. We work with Astrobotic and iSpace. And those were the first projects we won at Agile. That was before I got here. I've been at Agile a little over a year now. And yeah, back in 2019, I think is when we got the first iSpace contract. And in that case, the conversation was that we need a new capability that doesn't currently exist. It's not like you can go buy off-the-shelf lunar landing engines. It's been done. We did it back in the Apollo era. We can kind of look at that as, for examples, but we're doing a smaller lander and the engine just isn't out there. It doesn't exist. And the way Agile works is we've designed the company to be fast, essentially. I think that's one of the big needs in the space industry right now, is just the volume of things we're doing and how quickly we're changing things and how quickly we're putting up new capabilities. You got to be able to produce hardware at volume, but you also have to develop new hardware or customize hardware pretty quickly. And so the way we set up Agile is the test capability is in-house, which is kind of unique. It is, I don't know how familiar you guys are with vacuum testing for rocket engines, but it's a big hurdle to be able to do that really well. And the predecessor to Agile was a test company that eventually turned into a propulsion products company. And so we had these test stands sitting out there that we had been using to test Aerojet rocket engines, Moog engines, everything you can think of, and kind of built up that capability over time. And then we said, wow, if we can build an engine and then just walk across the street and test it whenever we want, and we're in control of that asset, we can move really fast, and we can be more hardware rich in our development. We can develop things quickly. And then we kind of designed the manufacturing process around being fast too. We, like a lot of folks, we heavily leverage additive manufacturing for rocket engines, which just makes a lot of sense for rocket engines. But since we have that in-house and we have all those materials and powders and stock in-house, we can say we're going to design a new engine. It takes however long to design it. It typically takes a day-ish to print it. Very small part count, you assemble it, you're testing it. And we've literally had customers come in where they have, we go from fresh sheet design to hot firing something in weeks, rather than months or years. So yeah, when it comes to developing a new capability, there just aren't that many companies that can move that fast and get serious hardware on a test stand hot firing stuff quickly, demonstrating that it'll work on orbit. So for things like lunar landers, that's where we come in. There just aren't that many companies that can do that. And then more, thinking almost chronologically as Agile, has matured, we've been able to make a lot of sales in the satellite market after we kind of demonstrated the developments we did with the lunar landing engines. And there it is kind of all about speed again. That's kind of the need we're serving, for Class A missions where there's a very long schedule associated with it. We work with those folks. We bid into those projects, but it's a little bit harder of a sell than buying the traditional heritage engines, even if the lead time is 24 months. But for a company that's trying to put assets on orbit in a year or 9 months or 18 months, they can't wait 24 months to get their engines. So that's often where the conversation starts, is just we can move really fast. And at this point, we have about 10 engines that we've developed. So when customers come to us and they need a certain thrust level, they need a monopropellant or a bipropellant, they kind of know what they need based on the spacecraft they designed. A lot of times we'll have a fit because just as time has gone by, we've developed a pretty good catalog of products. And then the conversation becomes, then we start talking performance. And a lot of times it comes down to what's your ISP, because we just want to have our mission last as long as possible, or we want to have as big a delta V as possible with the amount of propellant we can carry, or we want to minimize the amount of propellant we're carrying so we can maximize our payload. And that's all about ISP, right? It's kind of the main metric we talk about in the propulsion industry. And so that's kind of where it goes from there. But there are a lot of different kinds of engines. There's the attitude control side, where you want to have very small pulses, as controlled and small as possible to finally point your spacecraft. And then there's your main engines, where you want a lot of thrust over a longer burn. You just want it to be very efficient. Very different kind of products there, and kind of everything in between. And then lunar landing is a whole different, set of requirements there. That's a fun one.
That's a whole thing, yeah.
That's truly a whole thing.
Yeah,
remind us
kind
the
of how the conversation goes.
Remind us the parts of it's Griffin that you're working on with Astrobotic, but I forget which particular engines. It's the attitude control ones or the main ones. I forget.
Yeah, for Astrobotic, it's the attitude control engines for Griffin. So the vehicle has bipropellant main engines. So it's convenient to have the attitude control engines also be bipropellant. So they're relatively large, 110 Newton bipropellant engines. There's 12 of them on the vehicle, and that's what we're providing there.
Big boys. That's
Big boy.
Yeah.
Pretty big for attitude control. Yeah, absolutely.
Well,
it's a big mission.
I was gonna say, I don't want to step on it too much, but they've definitely been doing a lot of attitude control lately, so it feels like a thing that they care about. Yeah. Yeah.
Absolutely. Yeah.
What?
Oh dear.
Jake.
Yeah.
Jake's shaking his head. I mean, it's been a big week for attitude control. That's all I'm saying.
It has been a big week for attitude control.
Yeah.
Also for feed systems, just the upstream portion of the feed system, and yeah, I've enjoyed watching that, and all the press that Astrobotic's putting out is super cool. They've provided a lot of information, and all the pictures and everything is just amazing. I don't know how you guys feel about that, but it seems like the whole community is learning a lot from it. Space is hard. Those kinds of things happen. You can't blame them too much. And yeah, just the way they've handled it is pretty awesome.
Yeah.
It's also funny though because it felt like a major change from the way that they were handling communications before launch was much less open than post launch. And you could chalk that up to the combination of like Clips and NASA and ULA, and everything was all tied together. They were playing schedule chicken with Vulcan, and there was a lot going on. And then once it launched, it was like, I guess we'll just tweet everything. Like, we'll just tweet it all. We haven't determined if this thing in this picture is Earth yet. We think it is, but we'll let you know. Here it is anyway. Like, they definitely just went full on.
Unfiltered, raw.
Yeah. Which, yeah, and then, now, I mean, there'll be a press conference tomorrow where I'm sure we'll learn more about what was going on behind the scenes, but knowing that there was, most companies probably wouldn't take that approach. They'd be like, we don't really know what is going on with our spacecraft right now. We're trying to get a handle on it. Let's just not say anything until we know, and we can write the whole story all at one go. And then we'd have like 3 tweets from Scott Tilley of like, I think something's going on with this thing. Like, who knows what's happening? And we'd be able to like track it that way, but we wouldn't actually know. So it has been definitely a good test case in like how to approach this stuff. So I guess we'll see if any of the others take a similar approach. Being the first Clips mission is kind of interesting as well. Like, you're
lots of eyes.
Yeah, you're lots of eyes, and you don't really have a framework on how you should handle this.
Mm-hmm.
The first couple of human spaceflight missions that went up commercially, Inspiration 4 got a bunch of flack about like, where's my live stream? And it's like, well, they're just like hanging out in the spaceship right now. Like, they're probably sleeping or eating or something. They don't need to do the live stream the whole time like NASA did. So they had a rougher time with trailblazing how to communicate that stuff, whereas this felt like they were so open about it, and they were doing the best they could with what information they were getting. So, will Intuitive Machines also take that approach? Who knows? Are we going to see cool pics of the Agile engines next to the Crescent Earth when Griffin's on his way out? Who knows?
I hope so.
Yeah, you got to get a good camera angle. You got to like do next time you're out in Pittsburgh, just be like, so where are the cameras going to be at on this? Do the Canadarm thing.
Yeah. A selfie stick for those cameras.
Yeah. It's weird. Our attitude control engines come with their camera built in. It's a strange thing. It's just for us to classify performance of our engine.
I have a question about like the future. So, I mean, if you're trying to think about what is the next deployable structures bet that you want to make, but with your Agile engines, like what are you thinking is going to change in the market for the next, looking ahead 10 years, and what are you trying to do to like get ahead of that and be part of that?
Yeah, we've been thinking about that a lot, and there's so many problems out there to attack. It's stay focused, and kind of where we are now, honestly, is there is quite a bit of demand for spacecraft and for someone who can deliver propulsion systems on a reliable time frame that's a reasonable time frame. But some of what we've seen is, okay, it's great you guys can deliver your engines in 6 or 9 months, but the tanks are the first thing that go on the spacecraft, and we're waiting 18 months for those. So can you guys do tanks? We've literally gotten that question. So that's just an example of broadening out a little bit and solving propulsion. It made a lot of sense to start with the engines, the hard part. Maybe the hardest part. There are a lot of other, portions of a propulsion system that require a lot of experience and knowledge, and I don't want to, not account for that. But we started with the engines, which I think was the right call, but we need to solve the rest of the problem. So, full systems, tanks is something we're investing in right now. We actually did make a sale of quite a few tanks recently. So very new product for us. And yeah, we want customers to say, wow, okay, now we can build our spacecraft faster because all the propulsion components, which are one of the first things we integrate came in, quickly, much more quickly than we could get them last year. So that's kind of our goal right now, is to finish developing all the different engines that are in development, and then the rest of the propulsion system that's necessary to really give these missions the full capability they need.
Propulsion as a service.
Yeah, somewhat. I mean, really, customers react to that really well. If it's a big prime like a Lockheed, they have probably a bigger propulsion staff than we do, maybe. So they tend to want to just buy components, but they very much appreciate the fact that we understand the whole system, and we have folks that can talk the whole system and where whatever product they want to buy, whether it's a tank or a thruster or whatever, where it fits in. And then smaller companies, really appreciate someone being able to come in and just spec out the whole propulsion system for them and customize it for their spacecraft, or something we're looking at in the long run is thinking farther into the future. The Space Force and others are really wanting that without regret, which part of that can be solved with refueling. And there's a bunch of companies out there working refueling, doing a good job. I think we can help on kind of the propulsion development side of that, whether it's having a propulsion system that'll accept refueling services, and having all the tanks and feed system and pressurization system and everything in place that'll be reliably refuelable. And then the other one is thinking about things like, okay, typically, if you're running a monopropellant thruster on orbit, you do eventually run out of propellant, but you also have catalyst in there that's consumable. So the thruster itself, won't necessarily run forever if you just keep refueling it. So how do you address that? And do you replace those on orbit? How do you do that? Do you make the entire propulsion system modular, so that you, instead of refueling it, you just replace the full propulsion system? That's a problem we're really interested in solving. Is really enabling, for the Space Force and others, folks that have big geo assets up there and commercial satellites would like to operate them longer as well. And then there's folks working the servicing side of having the spacecraft that'll do the RPO and come up and conduct the operations to do refueling. So addressing kind of the hardware side of that is really interesting. So yeah, those are some of the future things. And then there's interesting work going on new and different propellants, green propellants, which really means lower toxicity propellants. And we're interested in working with the Air Force and others on solving that whole supply chain problem of the propellants we use now that are super reliable and high performance are also toxic, have the toxicity issue, which is at least perceived to kind of slow down the overall ground operations of fueling your vehicle and all that kind of stuff. It's harder to ship a fueled vehicle. Can be done, has been done, but most folks don't load their spacecraft with fuel and then ship it to the launch site. It's normally very kind of remote cases. So yeah, that kind of working through that whole supply chain issue, and just allowing us to get assets on orbit is interesting.
That's lots.
There was a lot of Colorado in that answer. There was a lot of Space Force and presumably Orbit Fab, and then you guys. That's a lot. I'm feeling like this is mainly a takeover by the Colorado Tourism Board. So that's great.
Yeah, we're gonna take over the world.
Colorado Chamber of Commerce.
And clearly, I got paid. I put it in my top 5 states. So definitely cashing out on this one as well.
We need to add the Instagram sponsor link at the bottom of this video here.
Hit us up,
Paid
Colorado.
promotionship.
Yeah, hit us up. We only got beer sent to us one time, but we've gotten 2 tourism board sponsorings. So be a weird market for us to hit. Seems possible. The test stand stuff that you were mentioning is, I feel like, low key the most interesting thing because of stories I've heard of the one test stand that got real backed up. And it was like, pretty much there's one test stand that got real backed up and it delayed several missions, one of which might crash into Earth tomorrow. Like there were some storylines there within the industry that are things that are like really, really niche, but really impactful when they happened. And, because I think we all think of test stands, we think of SpaceX and McGregor or Blue Origin and Van Horn or, the Stennis test stands. Like we think of big main engine test stands and we don't think of the other kinds up until they're the problematic part of a mission. Like all of a sudden we all care about Plumbrook because like 2 spacecraft going to the ISS needed to use it at the same time. We're like, well, this is going to be really delayed. At the time that James Webb went into the one at, was it Johnson Space Center where the like super cold test facility was like, I feel like test facilities are talked about never. And then they're like the highest priority thing that everyone's writing about one week. And then we all just ignore them again the next week. So they're...
The parachute stuff with some of the Mars landers went the same way, right? It was just like all of a sudden, if we don't get this parachute test done, it's over.
Yeah. And then there are also things that like, so if one mission finds an issue and then they take a little longer on that test facility, that's going to delay the next 3 that were waiting on that. And it just, it's such a storyline that nobody cares about until it's all we care about. And that's an intriguing part of, what I've talked to you about and Lars about how unique the test capabilities are. Like that's definitely not a thing to miss.
Absolutely. It's kind of interesting having come from deployables and now doing rocket engines. You can do tests on the ground, right? But to deploy out this really delicate, lightweight antenna in a 1G environment, you're always introducing a bunch of errors to the test because you're hooking up all kinds of things to it to offload it. It can't support its own weight under gravity. And then you're trying to do a communications test in some kind of anechoic chamber on an antenna that's meant to communicate from, across thousands of miles. And it's really hard to get a good test on the ground. Whereas with rocket engines, you put it on a vacuum test stand and fire it under the same scenario you're going to fire it in the mission. If it can withstand that, it's not going to have an issue with vibe loads. It's going through the most stress it's going to go through, and the thermal loads and all those kinds of things. Just operating it is where all those loads come from. So, you can get through. You can burn down most of the risk with propulsion systems if you do it, and if the test stands are available. By testing on the ground, is the way I think about it, coming from the deployables industry. But it doesn't always happen. I mean, there are companies out there that just don't have the test capabilities available, so they just can't build that into their program. They can't. There are even folks that manufacture engines and ship them without acceptance testing them, which maybe in very high volumes isn't a bad choice, but at this stage when we're delivering tens, hundreds of engines, we're acceptance testing every single one. And what we'd love to do is, do testing at a kind of more propulsion system level, to test the full propulsion system of the tank, as well as the full pressurization system, heat system, put it all on a test stand, test it together, rather than as individual components. And it really, there's risk and valve failures and all those kinds of things. And if you can do the environmental testing where you soak it through the right environments, get the right moisture and anything that's the propulsion system is going to be exposed to, and then test the whole thing extensively, you really can burn through a lot of the risk. Mm-hmm. Whereas with antennas, I used to say, We just need to fly it.
Just get us up there.
Just go.
Yeah. Tell that
it.
to the James Webb crew. That was like, all right,
Yeah.
well, we're gonna deploy this and undeploy it 18 times, and we'll keep trying it and repacking it, and then it worked. Everything went great.
Yeah.
Again, we only care about testing for the 5 minutes that everyone else cares about testing, and then we all forget about it. Well, it's been awesome hanging out. I don't know. I don't have anything else, Jake. You got any other? Did we miss anything?
No, I think we're good. Covered a lot
We
of
just got to go
ground.
to Colorado. Is I think the
Just
thing.
gotta
we
go to
missed.
Colorado. It's
Yeah.
the takeaway.
Absolutely.
Yeah.
You're invited anytime.
I mean, Jake was the one that missed out last time, so this
I
April's
did.
tough.
I mean-
Man, Space Symposium, they picked a tough week this year. They picked the same week as the eclipse. Like, ain't nobody going to that.
It's rough, isn't it?
It's really bad planning. They should have done any research into that and maybe shifted their week this year.
Yeah.
Let's start a petition.
Move it.
Yeah,
At
move
least
it
move
now,
it into the center line. Like, let's move this shit to Austin or something, you know?
No, you can't move it out of. I can't move it out of Colorado. We can't talk about that on this show.
Yeah, sorry, sponsors.
You
Sorry.
just ruined our sponsorship.
Oh, man. Well, all right. I guess I should quit before I get fired.
Thanks, guys. Good talking to you.
Thank you, Will.
Yeah.
We'll be back next week. What do we got next week? John Conifay.
John Conifay.
This new situation he's
Yeah.
got going on over at Integrate. Hot takes.
Mhm.
I think the last time you and I both talked to him, we were hanging out at that roof, on that roof.
The famous
at,
IAC roof.
IAC roof with Robert Lightfoot.
Yeah.
Yeah, we were in that
Robert
elevator
Lightfoot.
with him, and we were both too nervous to talk to him because we just like made a bunch of fun of him that several weeks before that show.
Yeah.
So
Yeah.
that'll be a good time. So that's next
Be a
week.
good time.
Yeah.
Yeah.
But until then,
Cool.
thanks for hanging,
Thanks,
y'all.
everybody.
Bye.
Ciao.
Cheers. Yeah.